The topic for today's video is distribution, joint and pair plot. Now, before starting the video, please subscribe to our channel and press the bell notification icon to never miss out on our videos. Now, let's see what are dist plot or distribution plots. We have many different plots for visualizing the data, like histogram or KDE plot. KDE refers to kernel density estimation, and we can have this two in one called as dist plot. So what dist plot does is this takes this histogram and KDE plot and plots it into a one plot. So dist plot is used to show the distribution of a univariate set of observations, that is one variable, or we can say of any one column of our data frame. So let's import pandas, seaborn and matplotlib. So we have this three imported. Then we have a data frame, placement data full CSV. Then we have a dist plot plotted. So we have dot dist plot to plot a distribution plot on the column SSC percentage, and we give bins is equal to 20. Now we have the bins of the histogram of as 20, and KDE is based on the histogram we have. So if you want to know what are KDE plots and you want to know more about KDE and KDE plots, so you can mention down in the comment and I'll surely make the video on it. So if we don't want this KDE and just we want the histogram, then we can pass in the function called as KDE is equal to false. Then we have only the histogram with 20 beans. Now let's see what are joint plots. Joint plot is used to show the distribution of a bivariate set of observations or two variables. So we have here HSC percentages and salary. It is based on two dist plots created. So it is basically we have two dist plots on x-axis and of y-axis created, and we also have a scatter plot of x and y of HSC percentage and salary percentage. We have scatter plots and also two distance plots plotted. So therefore it's called as joint plot. So we have scatter plot and dist plots plotted in one go. So as you can see, for HSCP we have this dist plot, and for salary we have this dist plot, and this is the scatter plot of salary and HSCP. Now let's see if we what if we pass hex into it. So hex will just have hexagonal shapes. Now you can see we have hex type into our joint plot. Now what if you pass kind is equal to reg? Reg means regression. So we have a linear regression or a linear line plotted onto the dots. Now as you can see, we will have a linear regression line plotted, and we also have the KDEs. The KDE is also plotted on our dist plots. So this is the use of joint plots to plot scatter plots and dist plots and KDE plots in one go. And let's see what are pair plots. So it plots pairwise relationships across an entire data frame, at least for numerical columns. So it plots the various possible graphs for the numerical columns in our data frame. So what are the disadvantages of it? So cannot be used when number of features are high. Cannot visualize higher dimensional patterns in 3D and 4D. Only possible to view 2D patterns. So these are the some advantages, but we can have n number of, or we can have all the numerical columns plotted in one go. Now you can see I have sns.pairplotdf. So this takes a while to print our result because it is very huge and we have many plots in one go. So let's wait. It's running. It takes time. So it will take time. Each and every pair plot just takes approx of 30 to 40 seconds, but if you have many number of numerical columns, the time will increase. Now let's see, we have for 1, 2, 3, 4, 5, 6, and this SL number 7. So we have 7 columns which are integer or float. Now we have 7 into 7, so 49. We will have 49 plots. You can see 1, 2, 3, 4, 5, 6, 7, and this 7. So we have 49 plots plotted. So that took a long time to plot. Now, what are these diagonal elements? Because this is SSCP and this is also SSCP. So these are histograms, but this diagonal distribution or this distributional plot along the diagonal are it gives an estimate of marginal distribution of each numerical data in our data frame. So these are all histograms, and other we have our scatter plots plotted. Then if we pass hue is equal to gender, then we can see the genders in each of the plots over here. So as if it is male, so it will be represented in different color. If it is female, it will be represented in different color in each and every scatter plot, and also in the histogram as well. So the histogram will be converted to KDE, I suppose. Let's wait for it to run. See, it takes a huge time. It takes time to run because we have 49 plots to plot. So it obviously will take time. So don't lose patience and just wait for some seconds. Now let's wait, and let's do one thing. We will also run these two functions, and then let's see what are the functions over here. So I will explain you this, then until that this two will be executed and we have the outputs, so we will not waste time. So as you can see, we have a subtitle which is my first plot. So my first pair plot is over here printed, but it is on the graph, so you can say it. But now you can see we have a legend which says gender male female, and then we have the KD plots instead of histograms, because we have two different males and females, and this is more accurate, or we can say we have this more convincing to have a KDE plot instead of a histogram. And other we have scatter plots, but we can see the blue is for males and the orange is for females. And now let's see what is SNS pair plot, and when we give hue is equal to HSCS. So let's see what is its HSCS has for us. So HSCS has arts, commerce, science, and arts. So we have this three. Then we will have three different colors, and we will have the same output as males and females. We will have a different legend, and we will have hex. We will have KD plots, and then the scatter plots of three different colors. So as you can see, we have three different colors which says commerce, science, and arts. In commerce in blue, science in orange, and arts in green. You can see this green and all. But if you observe carefully, this upper half means this 1, 2, 3, 4, 5, 6, 7, 8, and 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. Since these all plots, these plots and these plots before or below this marginal line and above this marginal line, these both are same. So you can just refer the charts or plots above the marginal line and have data, or you can have many insights out of it. As these two are same, you can have any referred. You can refer to this above one, or you can refer to this below plots as well. So it's the one and the same thing. You don't have to do it for all 49. You have to just do it for 19 or so. Now yes, we have SNS dot pair plot. Then we have hue is equal to HSCS, which is commerce, science, and arts. Then we have then we can specify which specific y variables and which specific x variables from our data frame we want. So in y column, I just want salary, and as x, I want SSC percentage, HSC percentage, and MBA percentage. And I give kind is equal to regression. So I have a linear regression line plotted for each and every hue, which is for chemistry, I have a different regression line. For science, I have different, and for arts, I have different linear regression line. And this height is equal to 6 tells that the plot has a height of 6. Then let's see, yeah, we have three different regression lines for each and every hue, or we have HSCS, HSC streams, commerce, science, and arts. So this is all from this video of pair plots. Then we saw joint plots. Then we saw what are disk plots. So hope you understood all those. And if you like the video, please press the thumbs up button. And if you have any doubts, put it down in the comment section and we'll get back to your doubts. Thank you.